I'm Marinko Spasojevic, and in this video, I will talk about implementing sorting in .NET Web API using Onion architecture. So far, I've already integrated pagination, filtering, and searching, and now it's time to complete the data handling process with sorting. Proper sorting is crucial for a great user experience, ensuring that data is organized and easy to navigate. However, if not implemented correctly, it can lead to inefficient queries and performance issues. So stay with me, and by the end of this video, you'll know exactly how to implement sorting the right way. As usual, if you like the video, please don't forget to hit the like and subscribe buttons. I'm pretty sure you're aware of how it helps me and the channel as well, so I highly appreciate it. That said, let's move on. So, as in the previous videos, I will start with the prepare project where I already implemented pagination, filtering and searching, and you can find links to all the videos in the description below. Now, I will first extend my abstract request parameters class. Here, I will add a new string property named order by to be able to send the ordering parameter to the action. With that done, let's modify the employee parameters class to enable the default sorting condition for employee if none was stated. So I will add a constructor here and set the value for the order by property to name. This is the exact architecture I use in my Web API online text course, with of course a lot more cover topics, which you can find published alongside our microservices and Blazor WebAssembly courses. So feel free to check out our new platform and explore all the courses available. Now, for me to be able to implement proper sorting logic, I need one library installed inside the Persistence project. The package name is SystemLink Dynamic Core, and I will provide the version here as well. With the package installed, I can move on by creating a new utility folder inside the extensions folder in this project, and inside it, I will add a new class. Let's name it Order Query Builder. So I need to make it static, and it will handle query generation for sorting. Inside this class, I will add a public static method that returns a string, and I'll name it createOrderQuery. This method will generate a valid sorting query based on the provided sorting string. It takes a single parameter, OrderByQueryString, which is the raw sorting string coming from the client request. Inside, I will create a new orderParams variable. Here, I'll trim the OrderByQueryString and split it by commas to separate multiple sorting parameters. This way, I can handle cases where the client requests sorting by multiple fields, like name ascending and age descending. Next, let's add a new variable here, where I will use reflection to get all public instance properties of the generic type T, using the getProperties method with binding flags public and binding flags instance. This allows me to check if the requested sorting fields actually exist in the entity class. Now I will create a string builder named OrderQueryBuilder, which I will use to dynamically build the final sorting query. With that done, let's iterate over each sorting parameter from the request. First, I will check if the parameter is empty or whitespace using the isNull or whitespace method. If it is, I will simply continue to the next iteration. Then, I will extract the actual property name from the parameter by splitting it at the first space. This helps separate the field name from the sorting direction. Now, I need to check whether the extracted property name actually exists in the T class. I will use the first-to-default method on property infos to find a matching property that has the same name, ignoring case sensitivity. If no matching property is found, I will continue to the next iteration, skipping the invalid sorting field. Now, I will determine the sorting direction. If the parameter ends with DESC, which stands for descending, I will set the direction to descending. Otherwise, I will assume ascending as the default. After that, I will append the valid sorting expression to the order query builder. The expression will follow the format property name direction, for example, name ascending or age descending. I also add a comma and a space after each sorting field to separate multiple sorting conditions. Once the loop is complete, I can convert the query to a string and trim it to remove any trailing commas or spaces. Finally, I will return the generated sorting query as a string. With this implementation, I now have a flexible and reusable way to dynamically generate sorting queries based on user input, while ensuring only valid entity properties are used. Great! Now, I need to modify the existing repository employee extensions class and add a new method that will handle sorting. So, let's create a public, static method that returns iQueryable employee, and I'll name it sort. This method will extend iQueryable employee, which means I can call it directly on an employee query. It takes a single parameter, order by query string, which contains the sorting instructions from the client request. First, I need to check whether order by query string is null or whitespace, using the isNull or whitespace method. If it is, I will simply return the employees ordered by name as a default sorting behavior. This ensures that even if the client does not provide sorting criteria, the results are still sorted in a meaningful way. Now, let's create a new order query variable to store the generated query. I will call the createOrderQuery of employee method from the OrderQueryBuilder class to generate a valid sorting query. This method will take the raw orderByQuery string and convert it into a properly formatted sorting expression, ensuring that only valid properties are used. After generating the order query, I need to check if it is still null or whitespace. If it is, I will return the employees ordered by name just like I did earlier. This prevents the application from executing an invalid sorting query. Finally, I will apply sorting to the employee query using the orderBy method. Instead of using the standard linkQ orderBy, I will use dynamic linkQ, which allows me to pass a string as a sorting expression. For this to work, I need to ensure that class includes the system linkQ dynamic core directive at the top. Excellent. The last thing I need to do is to change the repository method and call this new extension method with other features. So instead of the orderBy method, I will call a new sort method and provide the requested argument here. That's all. As you can see, with the properly structured solution, the logic is changed only where it needs to be changed. The rest of the solution is intact. Now, let's run the app and test this. So I will order the employees by name and then by age in descending order. And you can see the result. As you can see, the first two employees have the same name, but the age is different, and employees are properly sorted by the second condition. Of course, I can do it other way around. And now we have sorted employees by their names in a descending order, and then the age in an ascending order. Lastly, I can test this with all the previously implemented features, like paging, filtering, and searching. And I get the correct result, and if I check the headers tab, we can see properly generated metadata. So, that wraps up my implementation of sorting in .NET Web API using Onion architecture. Now, with sorting fully integrated alongside pagination, filtering, and searching, we have a complete and efficient way to handle data retrieval. If you found this helpful, you can like, share, and subscribe. And as always, feel free to leave any questions or feedback in the comments. Thanks for watching, and I'll see you in the next one. Until then, stay awesome.